to all of you again. And so, can you hear me well? Okay. Okay. And for your attendance, so we will practice the usual way. So, Prabhashana, please take the responsibility of getting the attendance. So, like previous time. And also, I prefer if you reflect your registration number. So, registration number. So then I can identify the participants. So if multiple participants are using one device, so please mention the whole registration numbers. Okay. So to get some idea, since you are using, you are sharing your devices with many students. So okay. So please for this link, so it won't charge for data. So it is free. Because so I'm using a LAN connection. So you won't charge for data, right? Like LAN එකේ තියෙන හන්ද මේ data වලට charge නැහැ, right? Okay. So let me share my screen. So can you see my screen properly? So can you see my screen?
Yes, sir.
Okay, thank you. So okay, last time we started linked list. So a different data structure, right? So let me quickly recall. So what we learned last time. So I think it will help for you to grab the content, right? So otherwise it may be boring for you. So if you have any questions, so you can raise your hand and ask, right? So since you are sharing devices, so please raise your hand, so then we can interact, right? So don't try to talk. Multiple participants, so it may be disturbed, right? Yeah. So if you have any questions, you can raise your hand, and then I will ask to talk. So okay. So if someone is talking unnecessarily, I will mute, right? So okay, let's keep that discipline in the class. So then so there won't be any disturbances, right? So I can easily conduct the lecture. Okay, if you have any questions, you can raise your hand at any time, and then I will ask you to raise your question, right? So that is easy. Okay. So last time we started linked list, and we went through some. So today also I will continue with linked list, and I will start some other data structures as well, right? So last time we discussed about linked list, how it look like and how to implement, right? So linked list is a sequence of data structures which are connected together via links. So it is connected via links. So it is having a data, a compartment for data, as well as a link for the next structure. It's kind of structures. So one structure is having a compartment for data, and one compartment to reflect the next container, right? So in simple, we can say it's kind of a container having two compartments. Container compartments දෙකක් තියෙන right එකක තියාගන්න data එක අනිත් එකේ තියාගන්නවා ඊළඟ container එකට තියෙන link එක right so in a graphical way you can easily recall, right? So here you are having containers. In one container you are having two compartments, right? One is to store data, other one is to store the next container, right? So මේ තියෙන්නේ containers ටික, right? මෙතන containers තුනක් තියෙනවා. එක container එකක් ගත්තොත් ඒකේ තියෙනවා data item එක. අපේ data එක තියාගන්න compartment එක, right? අනිත් compartment එක තියෙන ඊළඟ container එක මොකක්ද කියලා පෙන්නන්න. තියෙන තැන මොකක්ද කියලා පෙන්නන්න, right? So it's very simple data structure, right? So it is having a data field as well as a link field, right? So each link is linked with it is next link using the next link, right? Next link, next. What is next? Okay. And last link carries a link as a null, right? So to identify the last container, right? So okay, if there is no reason, I mean, please don't switch. Enable your mic. So if you have any questions, you can raise your hand and ask, right? So please keep that discipline. So it will be easy for us to continue, right? So thank you. Okay, the last item, the last container, the next is point to null. So which will help us to identify the end of this list, right? And also the first one we call head, right? So head will point to the first container, right? So then these are the two important things, right? So the last one, the last next is null. The first and the head is point to the first, right? So those are the important things you need to remember. And last time we discussed the type of linked list, right? Different types of linked list. So simple linked list. So in simple linked list, item navigation is forward only. Like ඉස්සරහට විතරයි යන්න පුළුවන්, right? Next කියන ඊළඟ containers ටික access කරන්න පුළුවන්. So which is called simple linked list. Second type is doubly linked list. So item can be navigated forward and backward. ඉස්සරහටත් යන්න පුළුවන්, ඒකේ පස්සරත් යන්න පුළුවන්, right? So we call doubly linked list. Circular linked list. So last item contain links of the first. So මේක අපිට roaming එන්න පුළුවන්. ඒ කියන්නේ end එකට ගිහලා ආපහු මුලට එන්න පුළුවන්, right? So we call circular, right? So the first one is simple, right? Item navigation is forward only. The second one is doubly linked list. Item can be navigated forward and backward, right? මුලට යන්න පුළුවන්, ඉස්සරහට විතරයි. Doubly linked list එකේදී ඉස්සරහට යන්න පුළුවන්, පස්සට යන්න පුළුවන්, right? Circular linked list එකේදී අගට ගිහිල්ලා ආයෙ මුලට එන්න පුළුවන්, right? So connected. Last item contains, and last container එක connect කරලා තියෙන first container, right? So last item contain link of the first element as next, right? And first element has link to the last, right? Okay, අග එක මුලට connect කරලා තියෙනවා, මුල එක අගට connect කරලා තියෙනවා, right? So then item navigation is easy, right? When we compare with simple linked list and doubly linked list, right? Okay, so those are the types of linked list. So last time we started with simple linked list, right? Simple linked list called simply linked list, right? So as I said earlier, so having one container is having two compartments, one for data, right? So one for data. So in this section we can store the required information. So all the required information will store in this data component, right? So it can be any data type. එතකොට මේ data කියන compartment එකේ තියෙන පුළුවන් ඕනම data type. For example, integer, char, float, double, right? For example, integer. char name 20. So that can be stored in the data compartment, right? So the next, that is called reference to the next node. So it will hold the next node address. ඊළඟ container එක කොහෙද තියෙන්නේ කියලා, right? So head node, starting node of a linked list. Last node is the node with reference pointer as null. එතකොට starting node එක head node කියලා කියනවා, right? Last node එක last node කියලා කියනවා, right? අන්තිමට තියෙන container එක, right? ඒකේ reference එක ඒකේ next කියන එක point කරලා දෙනවා null එකට, right? So now in this case in linked list, so there is a container. So to implement this container, we are using different data type. We call structure, right? So we container එක කියන එක අපි represent කරන්න structure කියන data type එක තමයි පාවිච්චි කරන්නේ. So every node is a linked list is a structure data type. Structure data type එකෙන් තමයි අපි මේ container එකක් define කරගන්නේ, right? So container එක ගුවම එක compartments දෙකක් තියෙනවා. එකක් data අනිත් එක next, right? So in the next slide you can see how we will implement. So here the samples simple linked list node, right? So on the right hand side you can see a container with two compartments, one for the data and one for the reference. So this is the structure, right? So how we will define in C, right? So this is the port segment which we will use to represent a node in a simple linked list, right? So මේක තමයි code එක අපි linked list එකක තියෙන එක container එකක් represent කරන්න use කරනවා, right? එතකොට මේක ඒ කියන්නේ structure කියන data type එකක node කියලා කියන්නේ මේක node එකක් container එකක්. එතකොට මේක data component එක integer, right? So in this example, this specific example, data component that is integer, right? In data. And then this is the reference. We call again this will represent a structure. So node next. The name is next, right? With the same structure, right? So this is how we represent this compartment, right? So where data used to store the integer information in this specific example, right? And struct node star next, it is used to refer to the next node. It will hold the address of the next node. Next node කියලා කියන්නේ ආපහු මේ node කියන જાතියම තමයිනේ. මේකෙන් මේ next කියන එකෙන් අපි represent කරන්නේ ආපහු node කියන වර්ගය. මේකින්ද struct node star next, right? So this is how we represent a node in a simple linked list, right? So very simple. So now so time to create and allocate memory for 3 nodes, right? So we last time we created 3 nodes, right? So head, middle and last, right? Right? So we created and allocate memory for 3 nodes, right? So this allocate memory is for the reference, right? So that is we call stack memory, right? I'm making one වර්ග දෙකක් තියෙනවා කියන. ඒතර මේ node කියන මෙන්න මේ next කියන එක ඇත්තටම තියෙන්නේ reference එක, right? ඒතර මේකට අපි කියනවා stack memory කියලා. So this part we call stack memory, right? So other part we call heap memory, right? Stack memory and heap memory. ඒතර අපි ඇත්තටම අපිට ඕන data ටික අපි දාලා තියාගන්නේ heap memory. So we will store our data in heap memory, right? So now let's look at how to create this structure. Okay, so the same code segment which I explained earlier, right? Struct node in struct node star next, right? So same code segment. So this is to create a container, right? Struct node in data struct node star next. So with this we will create a node, a container, right? And make container making හැදෙනවා, right? So now we will create 3 containers, right? Struct node කියන වර්ගයෙන් node කියන මෙන්න මේ data type එකෙන් head middle last, right? Head middle last, right? So now we created the 3 nodes, 3 containers, right? So the next step is assign memory or reference for these nodes, right? මෙන්න මේ component එක fill කරගන්න එක තමයි මේ කරන්නේ. reference එකට ඕන values ටික අපි දාන එක තමයි මෙතනින් කරන්නේ. ඒකට අපි ඒක assign කරගන්නේ system එකේ. ඒ කියන්නේ අපි අපේ memory එකෙන් තමයි ඒක ගන්න. right? එතකොට head කියන එකට දාගන්න memory allocation, right? Size of struct node. මේ මේකට head කියන එකේ reference value එක memory එකෙන් ගන්න කියලා තමයි මේ කියන්නේ, right? So middle එකට ගන්න. එතකොට මෙයා system එකෙන් assign කරන value එකක් තමයි ගන්න. So that is we call stack memory, right? So now stack memory is assigned, right? So with this, the system itself assign these values for the reference value as reference values, right? So the next step is assign values to each node, right? දැන් අපි මේකේ reference කියන එකට අදාළ values ටික දාගෙන ඉවරයි මේ nodes තුනේ. We call stack memory, right? So now the next step is assign value for data, right? So to assign values to each node, so we can write head data assign 10, middle data assign 20, last data 30. Now you can see this is we call heap memory, right? Now data component 10, 20, 30, right? So now individually these 2 parts are okay. Now we need to link, right? මේ head එකෙන් මෙන්න මේ node එක represent වෙනවා කියලා අපි කියනවා. මේ middle එකෙන් මෙන්න මේ middle node එක point කරනවා කියලා අපි කියනවා. මේ last එකෙන් last node එක represent කරනවා කියලා කියනවා. So that part is pending, but so these stack and heap memories are created with these code segments, right? So next step is linking each node, right? Linking each node. එතකොට අපි head next එක වෙන්න ඕන middle එක, middle next එක last එක, last next එක null, right? So can you remember? So the last one should be point to null, right? So with this code segment, we can link each node. So we are having 3 nodes, head, middle, and last. Head next is assigned to middle, middle next is assigned to last, last next is assigned to null. Null value assigned to this one, right? So null indicates the end of the linked list, right? So now see, head will point to the head node, middle dot next will point to the middle node, right? And the last dot next to point to null. Now this structure created, right? So this is the logical structure, right? So how it connects to each other. These containers are connected to each other, right? So this is head. This is the reference. The reference will help us to find the middle node, right? This is the value of the middle. And this is the reference of the middle node. So this will point to the last. And this is the data value. And the last node dot next point to the null. So that is the end of the linked list, right? So now you can understand how we can define this, right? So now last time we discussed print each node data in the linked list. කොහොමද අපි මේකේ තියෙන node data ටික print කරගන්නේ කියලා. So algorithm was given. So there we created a temporary node and assigned the head node address, right? So I will show you, right? So this is the linked list, right? So we are going to print 10, 20, and 30. So these are the values we need to print, right? Okay. First of all, we created a temporary node, right? And assign head value to this one, right? Because we need to keep this head node, this reference permanently, right? So if we remove this, so then we won't be able to identify the rest, right? So therefore we created a temporary node, right? And assigned to head, right? So then what we will need to do is, right, create a temporary node, temp, right, and assign the head node's address, right? Now print the data which present in the temp node. So that is the first element, right? So after printing the node, move the temp pointer to the next node, right? පළවෙනි එක print කරාට පස්සේ move කරන්න ඊළඟ එකට, right? කොච්චර දුරට අපි යන්න ඕනද? මේක null වෙනකන් අපි යන්න ඕනේ. So to identify the last one, we need to traverse through the end. So to identify the end, right? So the possible way is, so this one, I mean the last node next should be null, right? So that means we add the end, right? So okay, that is the algorithm, right? Print each node data in the linked list. So I think we discussed this, and we were able to write the C code as well as I can remember. Harshan, අපි මේකේ ලියුව නේද මේ code එකක් නේ? As I can remember, so we did up to that, right? So basically, to print each node data, right? Each node data කියන්නේ මේ linked list එකේ තියෙන data ටික පෙන්නනවා අපිට ඕන data ටික, right? So the algorithm is first create a temporary node, we call temp, and assign the head node's address. Then print the data which present in the temp node, right? ඒක data item එක ලියුවා. ඊට පස්සේ අපි ඒක ඉස්සරහට අරගෙන යන්න ඕන මේකේ end එක වෙනකන්. end එක කියන්නේ null, right? So after printing the data, move the temp pointer to the next node. Do the above process until we reach the end, right? මේක end එකට යනකම් අපි කරන්න ඕනේ. end එක අඳුරගන්නේ අපි last whatever last node dot next එක null නම්, right? So ඒක null නම් අපි කියනවා මේක අපි at the end, right? So done. Okay. So now here you can see the process, right? So this is the original linked list. So the objective is to print these values 10, 20, 30, right? So as per the algorithm, so we will create a temporary node and assign the head value. Head එකට තියෙන value එක මේ temporary temp එකට assign කරගන්න, right? See, මේ head එකේ තියෙන value එක මේ temp එකට assign කරගන්න, right? And then we will have an iteration up to temp not equal null. So it will happen, right? So print temp.data, right? Make a not null වෙනකන් යනවා. So කොහේ හරි මේක null වෙච්ච ගමන් මේ loop එක මේ iteration එක නතර වෙනවා, right? So then to keep the iteration, so we will assign temp.next into temp, right? So then it will go ahead. I mean, once you print this, it will go to this and print the data value and assign this, right? But this loop, this iteration will continue if temp is not null. Null වෙච්ච ගමන් මෙතන මේ iteration එක නතර වෙනවා. So this is how we will print that. So this is the complete code. I think so you can easily identify the code, right? So these are the required header files, and this is the main program. First of all, we need to create the structure, right? Struct node in, right? So they make a linked list එකක් integer data දාලා තියාගන්නවා, right? So simply we can say, right? So this is a node which can hold integer information, right? And then this is how the reference looks like. And then we declare 3 nodes, right? Head, middle, and last, and allocating memory, stack memory for each node, for head, middle, and last, right? Whether head, middle, last can stack memory assign කරගත්තා. ඊට පස්සේ ඒකේ තියෙන values to each node. So we will assign the values, right? And then connecting each nodes, right? To have the link. And then create a temporary pointer or temporary node, and then continue this iteration, right? Till the node becomes null, printing each node data, right? So the same logic, still, and finally return 0. So basically, this will print this data item 10, 20, and 30, right? I think this is where we stop, right? So in linked list data structure, we will focus on following basic operations. So insertion is to add an element at the beginning of the list. අපි කොහොමද linked list එක මුලට element එකක් add කරගන්නේ, right? කොහොමද අපි අලුත් value එකක් මේකට add කරගන්නේ, right? Deletion, delete an element at the beginning of the list. So කොහොමද linked list එක මුලින්ම තියෙන element එකක් delete කරන්නේ, right? Display, so displaying completes this which we already done, right? So at the last step we already done displaying complete list. And search an element using a given key. අපිට දීලා තියෙන key එක කොහොමද search කරන්නේ, right? Delete an element using අපිට දීලා තියෙන key එක කොහොමද delete කරන්නේ, right? So these are the basic operations we will discuss during this course, right? So we can add some more operations, but so we are limited to this scope, right? So these are the basic operations we will discuss in your course, right? Insertion, so that is to add an element at the beginning. Deletion, delete an element at the beginning. Display, displaying a complete list. Search, how to search an element by using a given key. අපිට දීලා තියෙන key එකක් කොහොමද search කරගන්නේ, right? කොතනද තියෙන්නේ? Delete an element using given key. අපිට දීලා තියෙන key එකක් කොහොමද delete කරන්නේ, right? So these are the basic operations associated with linked list data structure, right? Okay, now let's look at each of the operations individually. The first one is insertion operation, right? So it is very simple, right? So now this is the existing linked list. You can see. So this is the head, and this is the first node. This is the data item. This is the reference to the next node, right? So this is the next node, and this is the data item, and this is the reference. So this in this example we are having only two nodes, and the second node point to the null. So that means this is the end of the list, right? So this is the end of the list. So this is the given so this is the given linked list, right? So this is the given one. So now we are trying to insert a new node. So this is the new node, right? Right. So this is the linked list given, and this is the node we are going to insert, right? Right. The first step is this algorithm is create a node using the same structure, right? එතකොට මෙන්න මේ තියෙන structure එක තියෙනනේ, මේ තියෙන structure එකෙන්ම අපි මේක හදාගන්න ඉස්සෙල්ලා, right? And then we have to decide the location. මේක මුලට දානවද අගට දානවද, right? So we can insert at any point, right? So what in this course we will limit it to some locations, but you can insert at any location, right? So මේක තමයි given linked list. මේක තමයි given new node. So now we are trying to insert this, right? Maybe at the middle, maybe at the beginning, or middle, or at the end, right? Okay. So now let's look at the way how we will do this, right? So let me clear this. Okay. So see the second step. For example, if I want to insert this into the middle, right? So this is first, this is last, this is the new one, middle one, right? Let's say if I want to insert this new node into the middle of the linked list, right? Right. So imagine that we are inserting a node B. Then make a B කියලා, right? අලුතෙන් දාන node එක B. A කියන්නේ B, A කියන්නේ C කියන්නේ අපේ original අපිට දීපු list එක, right? Between A we can call left node, right? And C right node, right? Left node and right node, right? Then what we need to do is B dot next to C. See, දැන් මේ B කියන එක මොනවත් value එකක් නැහැනේ. දැන්ට තියෙන null කියන value එකේ, right? එතකොට අන්න A value එකට B dot next කියන එකට දාගන්න, right? B dot next කියන එකට දාගන්න C කියන එක. right? තේරුණාද කියන්නේ? right? එතකොට මේ අලුත් node එක new node dot next කියන එක represent කරනවා දැන් C කියන එක. right? එහෙනම් දැන් මොකද වෙන්නේ? දැන් මෙහෙම next ගාම මේ link එක හැදෙනවා. අනිත් එක මොකක්ද වෙන්නේ? right? Then A dot next කියන එක වෙන්න ඕන මොකද්ද? B වෙන්න ඕනනේ. එතකොට ඊළඟට වෙන්නේ අපි මේ link එක හදාගත්ත ගමන් අපිට තියෙන මේ link එක මෙතෙන්ට point කරන්න, right? So in the next step, see, now the next of the node at the left side, this side, left side, to the new node, right? Left node dot next කියන එකට අපි දාගන්න ඕන new node එකනේ, right? එතකොට මොකද වෙන්නේ? අලුත් item එක මැදට වැටිලා, right? මේ දෙන දෙපැත්තට ගියා, right? අලුත් item එකේ next එක දාගන්නවා අපි right node එක, left node dot next එකට දාගන්නවා new node එක. Very simple, right? So likewise we can insert a node at any position, right? So very simple. Okay, now think about this example, right? Inserting a node at the beginning of a linked list. So this is the given linked list, right? So before that, I would like to know how many of you completed this code segment. Because this will help us to understand linked list very well, right? How it looks like. How many of you completed this? Okay, no response. Okay, so let me show the code, right? So let me show you. List. So can you see my screen? Okay, so this time I am using Microsoft Visual Studio as my editor, right? So now I think so you are somewhat familiar with how to compile and run using Notepad and the command line, right? So now one step further, so we can use, I think all of your PCs are having Microsoft Visual Studio, I guess, right? So because you are learning. So you can freely download the community edition. So I will show you that as well, right? So please try to download and install the software. So if you are already having, so you don't need to install, right? So we call community edition, right? So it is free. So this one, right? So Visual Studio Community Edition. So you can download and install, right? So in my case, so I am using Microsoft Visual Studio 2010 Ultimate one, right? So this is the one I am having, right? But this one is latest one, right? So Visual Studio Community 2022, right? So you can download and install this free of charge, right? So this is a free software, right? So I'm using a somewhat old version of Microsoft Visual Studio, but this is ultimate version, right? So in this code you can easily identify, right? So the code segments and the keywords, right? So keywords in blue color, right? So and other statements in black color, right? And you can see it is color coded. You can easily identify your code segment, right? So but still I am trying to use command line to compile this. So this code segment is to define the structure, node structure, declaring nodes, right? Assigning values to each node, and then connecting each node, and then create a temporary, and then print all the elements, right? So let me compile this and show you. So right, so this is the code segment. So this is stored under. So I will show you where I save all these files. So this is in iDrive, right? So under lectures, linked list. So I will change my directory to this location, right? So basically change directory to this location. So, right, so okay, let's go right. So let me increase the font size so then you can easily see what I am doing, right? So this is 16, okay, the size. Okay, but this is a bit longer, right? So this maybe 25. Okay. Okay. So now I am in the location where I saved my file. So you can type dir command to see what are the files there. Okay. So you can check the compiler is available. So by typing gcc. So okay, compiler is there. So now you can say gcc, right? And the file name. So what is the file name? Print all, right? Print all. So you can just type P and tab. So then it will automatically fill, and then the output, right? Okay, then okay, print all. Just say print all. Just say print, right? So print and compile, right? So it compile, right? No errors. Now you can just type print, right? So because yes, is there, right? Sorry. PRINT. PRINT. Or TXE, right? Let's compile. Okay, once you compile, you can see the exe there, right? So this is the source code, right? And this is the exe after compiling, right? So now I'm trying to execute this, but let's see. Oh, sorry. Search found. Okay, let me check the code again. Check the code. Code is right. Compile it again. The problem is we have double quotes, right? So the problem was so in the previous one I put okay, this is GCC and the source file and the output, right? So I put quotes, see, right? So that's why I did not get the output, desired output. So in the latest one, see, GCC print all or print, right? So you can just type print and it will execute, right? So see, 10, 20, 30. Now, right? Okay. So now let me increase the font size. Then you can easily see. Right. So by using this kind of development environment, right? So you can easily write the code, right? So previously we used Notepad, so which is somewhat complex because you can't identify these code segments, right? So these indentations is very difficult, right? So here you can see, for example, if I want to check the main code segment, see, so you can extract or extract. For example, if you want to extract this one, right? See, this is the data structure. So this is the open disclose. So you can easily identify the code segment by using this kind of tool, right? So now let's try to work with Visual Studio, but still let's try to compile the code with command line. So as the next step, so we can directly use Microsoft Visual Studio to run. See, you can see start debugging here, right? So but so I'm not using this at the moment because you need to understand the concept, right? So let's try to go with one step forward, right? So try to write your code using Visual Studio and compile using command line. So next step, what we will do is, right? So we will use only the development environment, Microsoft Visual Studio. You can compile C programs also by using Microsoft Visual Studio, C, C++, C Sharp, so C Sharp.net. So whatever you can use this single interface to write, compile, and run the program, right? So very easy. So that is our next step, right? So just want to show you how we can use this development environment, right? So from today onwards, let's try to use this tool, right? So Visual Studio. Okay, I hope all of you completed this step, right? So basically, the code segment is to print all the elements in a given linked list. But initially we create a structure node, right? So this is to create a container. අපි දැන් අර කතා කරන link list එකේ තියෙන container එක හදන්න use කරන code segment එක තමයි මේ තියෙන්නේ, right? Struct node. So just to explain this further, right? And then so I created 3 nodes, right? from මේ අපි හදාගත්ත struct මේ node එකේ, right? මෙන්න මේ node එකෙන් මම හදාගත්තා head middle last කියලා containers 3ක්. right? So ඊට පස්සේ මොකද කරේ? දැන් අපි මේකෙදි කතා කරන්නේ link list එකක් නේ. ඒකට ඒකේ මේ එක node එකක් ගත්තොත් එක container එකක් ගත්තොත් compartments දෙකක් තියෙනවා. ඒකට ඒකේ එකක් තමයි reference එක. next එක. right? So ඒක අපි allocating memory for each node. ඒකට ඒක අපි system එකෙන් තමයි මේ value එක allocate කරගන්නේ. මේක අපි store කරලා තියාගන්න value එකක් නෙමෙයි system එක assign කරන value එකක්. හරි? මේ තියෙන්නේ head එකට system එක allocate කරමු memory එක. මේ තියෙන middle එකට system එක allocate කරමු memory එක. මේ තියෙන last කියන එකට system එක allocate කරමු memory එක. හරි. දැන් අපි node කියන එක හදාගත්තා. ඒවයින් තුනකුත් හදාගත්තා. ඒකේ reference එකට එන්න ඕන memory ටිකක් දාගත්තා. ඊට පස්සේ අපි ඊළඟ එක තමයි assign values. අපි store කරලා දෙන values ටික අපි ඊට පස්සේ assign කරගන්නවා. අපි තියාගන්න යන්නේ 10 20 30 කියලා values තුන. right? එතකොට head එකට දාගන්නවා ඒක data එකට 10, middle එකේ data එකට 20, last එකේ data එකට 30. හරිද? sorry. ඊට පස්සේ මොකද අපි කරන්නේ? මේක එකට එකක් link කරන්න ඕනේ. දැන් අපි මේක head middle last කියලා individually, right? separate containers හදාගෙන ඒවට ඕන reference value එකයි data එකක් දාගෙන ඉන්න. The next step is we need to link these nodes, connecting each nodes, right? Okay, then head next, middle next, last next, null. හරිද? ඊට පස්සේ මොකද කරන්නේ? මේ වෙනකොට අපි දැන් මේක හදලා ඉවරයි. මෙන්න මේ structure එක හදලා ඉවරයි, right? So I'll just show you. Okay. Method එනකොට, right? So struct node up to this point, right? Up to this point එනකොට මෙන්න මේ linked list data structure එක හැදලා ඉවරයි, right? 10 20 30 මේ ටික හැදලා ඉවරයි, right? ඊට පස්සේ ඊළඟ step එකෙන් කියන්නේ කොහොමද මේක ඉතින් මේ items ටික print කරන්නේ? එනියම ගෙනත් දෙන්නේ, right? එතකොට අපි ඒක කරන්නේ temporary node එකක් හදා ගන්නවා. ඒකට head එකේ value එක දාගන්න. right? temporary node එකක් හදාගෙන මේ තියෙන temporary node එකක් හදාගෙන head එකේ value එක දාගන්න. right? this step. ඊට පස්සේ මොකද කරන්නේ? ඊට පස්සේ till the node becomes null. හරිද? මේ next එක null වෙනකන් අපි printing each node data. මේ හැම node එකේම තියෙන data එක print කරනවා. right? so then I use while loop, while temp not null, right? print temp data. Right? To keep this loop, so we will what we'll do is we will assign temp dot next to temp, right? Then it will forward, right? එතකොට මේක කොහේ කරකදී null වෙච්ච ගමන් while එක යනවා. එතකන් අපි මේ ටික print කරනවා, right? right? එතකොට මේක print කරනකොට මේක print කරන විදිය, right? එතකොට මේක මේ වගේ ඉතලයක් දාලා පෙන්නන්න කියලා තමයි කියලා තියෙන්නේ, right? right? So once you run this, right? So this is print, the exe is print, see? It will print 10, right? Arrow 20, arrow 30, the last one is null, right? We print the null as well. Right? Very easy. So this is print all one. Okay, now let's move into our presentation, right? So let's quickly Okay, so I explained this code segment by using Visual Studio, right? So next step is operations. So insertion, deletion, display, search, and delete. We discussed this. So then we come to insertion operation, right? In insertion operation. So this is the existing. So this is the given linked list, and this is the node we are going to insert, new node. So what we will do is very simple, right? Let me clear this. So this is the original data structure. This is the new one. So then we will assign new. We will assign the last node to new node.text, right? So then this link created. Okay. Right. In other words, you can say new node.next right node, right? So new node.next right node. Right. What is the next step? First node, I mean the left node.next should be the new node, right? So this one. This is left node.next new node. So then this link removed and we created two links, right? So new node.next, that is right. Left node.next, that is new node, right? So that means this item inserted, right? Okay. So now example given, right? Inserting a node at the beginning of a linked list, right? එතකොට මේක තමයි අපිට දීලා තියෙන linked list එක. Right? See, this is the given linked list, right? Okay. What are the elements? 20, 30, 40. And this is the end of the linked list, right? So now we are trying to insert 100 at the beginning. Inserting a node at the beginning of a linked list, right? එතකොට අපි 100 කියන data item එක මෙන්න මේ දීලා තියෙන linked list එකේ මුලට insert කරන්න කියලා මේ කියන්නේ, right? 20, 30, 40, none. So this is the input. Once you insert 100 into this linked list, so the new linked list becomes 100, 20, 30, 40, none. Right? So what is the algorithm? So same thing, right? Declare a head pointer and make it as null, right? So create a new node with the given data. Make the new node point to the head node. And finally make the new node as the head node. Right? It's very simple. Make a monitor lazy. Right? So now see in graphically. Okay. So first declare the head pointer. Right? Head pointer, right? And make it as null. Right? So this is the code segment to create a node, right? So always we are using this, right? Struct node. So integer values we are storing, and this is the next, right? So this one. And then same time, what we will do is this, we will assign null to this head node, right? Head kela node එකක් හදාගන්න node කියන වර්ගෙන්න, right? Assign කරන null කියන, right? And then create new node with the given data. Then අපි අලුත් node එකක් අපි හදනවානේ, right? එතකොට struct node new node, right? මේ තමයි අලුත් node එක. 100 කියන node එක, right? New node. So this code segment will use to assign value to the new node, right? Struct node, new node කියලා හදාගන්න node කියන data structure එක, right? එතකොට මේකේ stack memory එක assign කරගන්න, right? ඊට පස්සේ ඒකේ data එකට, right? New node data එකට දාගන්න අපේ value එක. In this case 100, right? In this case 100. Okay. So what is the next step? Okay, now make the new node point to the head node. Okay. So now we are having a head node, right? At first, struct node head, right? Create new node. So this is we already discussed. And now what we will do is new node next head, right? So head එකේ තියෙන value එක දාගන්න new node next එක, right? Okay. So very simple. And then right? So we will assign the head to new node, right? New node value, new node කියන එක assign කරගන්න head කියන එක. එතකොට අපි මෙන්න මේ විදිහේ data structure එකක් හැදෙනවා, right? So head null. So this is the value and this is the value, right? So this is the value we are storing and this is the reference value, right? Or otherwise called a link. I mean, and then this is the new node, right? Point to null. So once you done, so this one container created, and again we are assigning head null, right? So now, okay, now we inserted 10. So the next step is insert 20. Okay, now insert 20, right? So then what we'll do is, okay, so this is already there, and then the new node next become the 10, right? So okay, like this, and now insert 30, right? So now all three items are inserted. So now this data structure created, right? So what we are trying to do here is, right, add first. With add first, we can add all these elements, right? Because we are trying to add the new items at the beginning, right? So now insert 10, then insert 20, then insert 30. Now we created all three items, right? So now this is the program to insert node at the beginning of a linked list. And this, here I create a function called add first, and I call this function 3 times, right? So to add this 10, 20, and 30. So this is somewhat similar to this program, right? So the previous one, right? Here we created 3 nodes and assign values. But here I created a function called add first, right? But add first එක තුන්පාරක් call කරානම් we can do the same, right? So this is the first call, insert 10. This is the second call, insert 20. This is third call, insert 30, right? So this add first code, right? So this is the add first. See, this is the add first function, right? So void add first. So right. So this is print list function. So I separated add first and print. Finally, we will create the main program, right? And we will call these functions inside this main program, right? So now you are learning how to write a function in C, right? So at the beginning, we only use the main function, right? So main program. But now we are trying to create separate functions, right? So one is to add elements. One function is to print, right? One is to add, one is to print. So we are calling this inside the main program, right? So now try to understand this code segment. This is very easy, right? First of all, we created this structure data type, right? So you need to understand all these 4 components, right? So these are the libraries. So as always, what are the required libraries? So you are okay with this, right? These are the libraries we need. And then create the data structure. So this node is in structure data type. So this structure data type can store 2 types of data. One is the data component, other one is the reference component, right? So this is okay. You are familiar with this, right? Now I am creating a function called add first. So now I am thinking at the beginning, right? At the beginning, we don't have any element in the list, right? So add first means we will add the value to the beginning, right? Okay, now we are trying to add this value. So we are passing these variables to this function, okay, value, right? And also we are passing the head node, right? Okay, now create the node and allocate the memory and assign the value and assign the head value to this and finally created the container, right? Like this. And this is the value, right? So whatever the value here, whatever the references here, right? Now this is created. So now print list. So we discussed this, and we wrote this the whole code in the main program. Now here we try to separate the print part, right? So now first assign temporary node, and this loop will execute temp null, right? So then print temp text to iterate and then print, right? So it will print the values. Right? Then we call these functions inside the main program. Okay, now we are trying to insert three values, right? Initially, we need to assign null value to the head, because if there are some values in the memory, so it will give you wrong output. So therefore, initially we will assign null value to this, and then at 10, at 20, at 30, right? And then print 10, right? Then it will print 10, 20, 30. Right? So, okay. So once this will execute, first we'll create 10, right? So this will happen once you execute this, and then once you insert 20, it will add this to the beginning, right? So like this. This is 20, and point to this, right? So once you execute this, again it will create a separate node called 30, and point this. So like that, you can easily add a node to the beginning of a given list. Right? එතකොට අපිට මේකෙන් එතකොට beginning කියලා කියන්නේ දැන් මුලදී ගත්තම beginning කියලා එකම item එකක් ගන්න 10ක් දුන්නා, right? ඊට පස්සේ 20 මුලට දැම්මම මේක create වුණා, right? ඊට පස්සේ 30 මුලට දැම්මම මේක. එතකොට මේකෙන් අපිට පුළුවන් මේ linked list එක හදාගන්න, right? So with this code, the same thing, right? So what we did previously, but this time we created two functions. One is to adding items, one is to print items, right? So print items, adding items, right? Okay, now let's try to write this code. So if you already tried the previous code, I think this code become very easy, right? So let's try to write this code. ඔබට power ආවද? ප්‍රභාෂණ? No response, Prabhashana. So I know only Prabhashana. Vidyaratna. Power ආවද?
ඇහෙනවද?
ඔව් ඇහෙනවා. ඇහෙන්නත් ඔය ගාමඩ ඉස්සලා. ඔයාලට power ආවද? ඔයගොල්ලන්ගේ laptops වල වැඩ ගන්න පුළුවන්කම තියනවද?
ඔව් සර් කරන්ට් එක ඇවිල්ලා තියෙන්නේ. දැන් ටික කලින් ආවා.
හරි හරි. ඔයගොල්ලන්ගේ laptops වල වැඩ ගන්න පුළුවන් නේද?
පුළුවන් සර්.
හරි. එහෙනම් මේ අපි මේ program එක බලමු ලියන්න. දැන් මේ same program එක අපි කලින් කරා, right? අපි last week එකේ කරා program එකම තමයි, right? So the same program, right? This one. So we write it a different way, right? මේකදී අපි කරේ 10 20 30 කියන මෙන්න මේ data item තුන දාලා link list එකක් හදපු එක, right? හැබැයි මේක අපි ඔක්කොම ලියුවේ main program එක ඇතුලේ, right? So now we are trying to separate, right? So with this one, right? We are creating two functions, and we will call these two functions inside the main program, right? Okay, let's try to create this code. Okay, let's take around 15 minutes to write and compile this code, right? So, okay, so let's start. So I will do parallelly, right, to you. Okay, let me, okay. Now, what we are trying to do is same code in a different way, right? So, okay. So to create a new file, so you can easily select, okay, text file now. Okay, just open C++ now. So script web C#. I just create text file and then we can save this. Okay, so you can use this screen. Okay. I think I already shared this PowerPoint, right? So you can refer to this PowerPoint and try to write this code, right? So quickly, let's take around 10 to 15 minutes and try to complete, right? Okay. Same time I am working on other screen, right? So that is easy. Insertion. You can refer the note given, right? So I have already circulated this PowerPoint to Harshan. I think he already forwarded to you, right? So this is the code, right? So I call this is insertion because this will insert at the beginning, right? So at the beginning of the list, right? So basically, these are the header files, and this is the node data structure, right? And at first, basically create a new node, right? And assign the new node and assign the value and assign the node, right? And then this is print list, right? Basically, assign a temporary node and execute this loop and print, right? And this is the main program. Basically, it will assign the head null to the head, and then at first we call head, right? Head, and at first 20 at first 30, right? And then print list, because with this function we will be able to write the print list and return 0, right? So to complete the main program, right? Exit, right? So now let's try to compile this. So the code is insertion, I mean the insertion.c. Okay, let's try to see the files there. Okay, insertion is there, right? So this is the file, right? Now let's try to compile this, right? So using GCC compiler. So this is insertion and the output. Maybe let's say this is insertion also, right? Okay, compile this. Okay, so no errors. Then you can write the name of the exe, right? Insertion, right? So it will create the same data structure, right? 10, 20, 30. Okay. So now time for you, right? Let's quickly write this code and compile. So after this, I will give a short break for. So normally, Harsha, Prabhashana, what is the procedure? So at what time you will take your lunch? Because as per the program, right? So this is I'm confused with this. So this is the timetable, right? As per the timetable, 11:15 to 1:15 and 1:15 to 2:15. So normally you will get lunch at 2:15, because the next lecture will start at 15. That means 3. කියන්නේ මේක 11යි කාලට පටන් ගත්තම 2යි කාල වෙනකන් යනවා, right? Then the next one will start at 3. So එතකොට මේ 2:15 to 3 වෙනකන් one time එක තියෙන්නේ. ඒක lunch වලට තියෙන time එකද? ප්‍රභාෂණ. For anyone else, no problem, right? So you can talk. Lunch time එක කොහමද ඔයගොල්ලන්ගේ? Or something else? Hope you are doing the task assigned, right? Okay, let me. Right. So basically, this is the header files required for this code, and this code will create the node in the structure data type. Right. So basically, it will store integer data, and then this is the reference to the next one. Right. So which is also with the data type node. Right. We have with the pointer next. Right. So this code segment to add first. Basically, we will pass the head node and the value required to be inserted for insertion to the list, right? And then we will create the new node with the same data type and assign the stack memory, and then assign the heap memory, right? And assign the head, right? So then print, we are passing the head. I mean, whatever the linked list, right? And then create the temporary pointer, and then move through the list and print whatever values, right? And then here we call the main program. We will call okay, this is first of all assign null value to the head, and then add value 10, and then add value 20, and then add value 30. And the print list. Basically, first it will insert 10, and then 20, and then 30, right? Okay, so this is the complete code. And so to compile, so you know what is the command we need to use. We are using GCC compiler, and this is our source file insertion.c, right? See, insertion.c, right? And then this is the output, right? The exe name is insert, right? So then we can compile this, no errors, and then run the program, right? Very easy. So the program name is insertion, not insertion.c. Insertion.c is source file, right? So then then it will print. Okay, first insert 10, 20, 30, right? So that is how we will insert data to the linked list. Okay. So anyway, I will give this exercise as an assignment, right? So still, I already received LMS account, but I have not enrolled. I was not enrolled for these courses. So therefore, I'm not in a position to upload assignments to LMS yet. But I will. What I will do is I will I will create the assignment and send to Prabhashana. So Prabhashana will forward it to you, right? So like what we did earlier. So I will I will share the assignment with the deadline. So with the deadline. So this time, so please adhere to the deadline because I already created the email address and there won't be any issues with the email address, right? So last time we had an issue with the email address, but now the issue has been fixed. So therefore, you will be able to send your assignments to the email address without any issue, right? So now, so we discuss about this program to insert a note at the beginning of a linked list, right? So I think can some of you share if you already done this code segment? So I can give you the sharing permission, so then I can see what you are doing, right? So if you like, so you can share the program, what you have done, right? So I have given permission. So if one of you already did this, please share your screen, then I can recognize you are doing this, right? Can one of you voluntarily? So no interaction, no interaction at all. Can one of you please share your screen and explain what you did and the results? Anyway, I will give this as assignment. So you have to send your answers, right? So with that, I will move to the next operation, right? So because we need to complete this and we need to start queue and stacks today, right? So therefore we need to be hurry. This program is to insert note at the beginning, right? So let's see inserting a note at the end of the linked list, right? අපි කලින් program එකේ කරේ මේ linked list එකේ මුලට item එකක් insert කරන්න, right? So now let's look at how to insert a node at the end of a linked list. Okay. So there are some sample input and output given. For example, this one, right? So let me. Okay. Okay. So now I think you can see my screen, right? Okay. So what is the meaning of this insertion, right? Inserting a node at the end of, right? So this is the given linked list, right? So this is the given linked list, right? And we are trying to insert 50, right? So then what will be the output? So it will insert at the end of the linked list, right? So then after 40, right? So 50 here, right? Once we execute this, right? Okay, if the input is null, right? So I mean, if we were given a null, I mean, no items, no nodes. So then what will happen after inserting 10? So like this, right? So only 10, right? So then you can understand two cases, right? If the list is null, So only one element will be inserted. If the list is not null, it will insert at the element. I mean, it will insert the value at the end of the linked list, right? Right. Okay. So what is the algorithm? So first of all, declare head pointer and make it as null. So as usual, right? Create a new node because we are trying to insert new one with the given data. So in this case, 50, and make the new node next as null because this new node, because we are inserting at the end, right? So then the new node dot next should be null because the new node is going to be the last node, right? If the head node is null, so basically that is an empty linked list. So like this, and make the new node as the head, right? So then only one item. If the head node is not null, linked list it already has some elements, right? Like a not null already has some elements. Then to find the last node, right? So basically we need to find the last node, search the last node, make the last node next as the new node. So I think visually you can easily understand, right? So the same thing. Okay, I will show you. Okay, step 1, declare head pointer. So as usual, okay, struct node in data, struct node next, and assign null value, right? Step 2, create a new node, right? Assign the stack memory, heap memory, and the new node next null, right? And then if the head node is null, right? If head null, then the new node value point to head, right? Make the new node as head, like this, right? If head is null, then the new node, and assign head, right? So this is the first step. This is the second step, right? If head is null, that means no elements, and this element will be the first element of this linked list, right? If head is null, right? It is an empty list, right? So then if head is equal to null, then the new node will assign to head, right? New node will assign to head. Okay. Otherwise, find the last node and set last node. Then the new node will assign to the last node, right? So then at last, right? So this create new node, and not if head is null, it will be the first node. Otherwise, we call else, then struct node, last node head, right? If last node is address will be null, so this is if it is null, right? Otherwise, it will assign to this value, right? Last node next should be new node. That means the last, I mean, it is not null, right? Very easy, right? So see visual representation. Let's insert a data tape, right? If head is null, then this will be the right. Let's insert 20. So then this will point to 20. So it will insert 20 at the last, right? And let's insert 30, right? This will point to the 30, right? So this is the complete implementation of inserting a node at the end of the linked list. So basically the same thing you need to practice. So here also I created two functions. One is to add at last, and one is to print list, right? So very easy. So these are the header files. I'm trying to explain the code segments header file, and this is the data structure, right, with the node, right, and then add first, right. First create the node and assign value, right. So, right, and head is null. That means empty list, right. So very easy. Execute this, right. That means it is not null, right? Then we need to find out then to go through the linked list. It is right, and then last node. Once you find out last node, then last node next should be new node, right? So printing is very similar as previous. First assign the head value, to temp1, and this execute this load, right, and the print. Now this is the main program, right? First, assign null value to the head, and then add 10, add 20, add 30, and then print list, and return 0 to freeze up the memory. Okay, so this program will help to insert a node at the end of a linked list. Linked list එකේ අගට element එකක් add කරනවා කියලා. කලින් එක කරේ මුලට, right? So you can see the difference. So this program code will help to insert a node at the end of a linked list, right? So previously, what we did was insert a node at the beginning of a linked list, right? So now you know how to insert at the beginning, how to insert at the end, right? So if I want to insert some value in the middle, so then the value should be given, right? මේ link list එකේ මැදට කොහේ හරි දානවා නම් අපිට ඒ value එක කොතනද දාන්න ඕන කියලා කියන්න ඕන, right? So then beginning and end කියන එක it's clearly defined, right? So if it is middle, then we need to give the value. What is the value? Right? So based on that, we'll be able to insert, right? So okay, so that is about insertion, right? So now the next step is deletion. Next operation is deletion operation, right? So basically we need to find out the target and then delete, right? So then two operations will be executed here. One is to search item, right? Other one is to delete, right? Search and delete. So both operations we will discuss here, right? So okay. Okay, I will give you 10 minutes, 10 to 15 minutes break because I want to do some calls, right? So please take 10 to 15 minutes break. Then I will start with the deletion operation. So Prabhashan, are you there? Prabhashan, are you not there? Okay, let's take 15 minutes break. So then we'll join after that, right? So today we will conduct the class up to 2:15, right? So after the break, please come to the class, and I will complete the rest, right? So if no one is talking, so I can observe less interaction. So that is not good for online classes anyway. So if you are talking, it is good for me to conduct this lecture interactively, right? So otherwise it is kind of boring anyway. So let's take 10 to 15 minutes break, and then after that I will start. I will continue the class up to 2:15, like today, right? Okay, thank you. Okay, welcome back. Uh, so can you hear me properly? Okay, anyway, so I know I discussed with Prabhashana about your difficulties. So due to power issues, so you are having only few PCs to access, and you are recording in one PC. So that I understood, right? So it's okay. It's kind of practical limitation. Okay, so let's focus on deletion operation, right? So here we are trying to identify some target node. So target node that need to be deleted, right? So in this diagram, you can see. Okay, let's open annotator. So this is the target node to be deleted, right? Make one delete command, right? Make a given linked list, right? So this is the given linked list. Making මෙන්න මේ target node කියන එක. එතකොට මුලින්ම අපි කරන්න ඕනේ මේ target node එක හොයාගන්න ඕනේ. මකන්න කලින්. Right? So locate the target node to be removed by using searching algorithm. Okay. Then deletion operation involves with two things. One is to find out or search this target node and then remove. Right? Remove it. So now let's look at the algorithm for this. Right? So algorithm for this. Right? So okay, so this is the algorithm, right? So the left or the previous, this one, node of the target node now should point to the next node of the target node, right? So once you find out the target node, right? So once you find out the target node, right? So this is the target node, right? So this is the left node of the target node. This is the right node of the target node. Right? එතකොට මේක තමයි target node එක, target node එකේ left එක තමයි මෙයා, ඒක right එක තමයි මෙයා. Right? So now once you delete this, මොකක්ද අපි කරන්න ඕනේ? මෙන්න මේ left node එකේ next කියන එක කෙනා target node එකේ next කරගන්න ඕනේ. දැන් එතකොට මේ තියෙන left node next, right? දැන් මේ left node next තියෙන එක කෙනාට අපි දාගන්න ඕනේ target node next එකේ තියෙන value එක. එතකොට මොකද වෙන්නේ? මෙයා automatically අයින් වෙලා මේ දෙන්න link වෙනවා. So very easy, right? So left node dot next කියන එකට අපි දාගන්න ඕන target node dot next කියන එකේ value එක. So very easy. So now left node dot next should refer to the target node dot next. So then target node will automatically fill. Right? So but we will keep this target node in a temporary node. So if you don't need this temporary node, we can remove the target node later. I mean, the memory we can delete later. So this is the algorithm for deletion operation, right? So very easy, right? And then now we shall remove to what target node is pointing, right? So then we will assign the null value to target node dot text, because see, once you remove this, then we will assign target node dot text null, right? So then it will keep store in somewhere in the memory, right? If you don't need that, we can remove that as well, right? So that is the deletion operation, right? So deletion operations, we need to use the deleted node. We can keep that in memory. Otherwise, we can simply deallocate, right, memory and wipe off the target node completely, right? So what we can do is we can delete this and we can hold the memory in a temporary location. If we don't need that, we can simply deallocate the memory and wipe off the target node completely. So then it will remove the memory of the target node, right? So we don't need to keep unnecessary things in the memory. So if you think you don't need, we can easily deallocate the memory. So here you can see deleting a node in a linked list. So here you can see this is the original linked list given, right? So in our case, right? So having three elements, 10, 20, and 30, right? Having three elements, 10, 20, and 30. Right? Now we are trying to delete 20. So basically we need to give the item to be deleted, right? So then input is 20. That means we need to delete 20. So then the output should be like this, right? Once you delete this 20, so then two items are remaining, 10 and 30, right? So if you delete 30, so 30, then 10, 20. The output should be 10, 20, right? So with this, you can easily understand what is deleting a node in the linked list, right? So this is the given linked list, right? So now I want to delete 20. So this is the resultant linked list, right? So once you delete 20, 20 is the middle item, then the remaining items are 10 and 30, right? So once you delete 30, so the remaining items are 10, 20. So this is the input, this is the output, right? So very easy. So algorithm we discussed previously. If the head node has the given key, right? අපි තුමු දැන් මේක පටන් ගන්නකොටම පටන් ගන්න තැනම තමයි මේ key එක තියෙන්නේ, right? Make the head points to the second node and create this memory, right? Otherwise, from the current node, check whether the next node has the given key. මේක අපි loop එකකට දාලා බලන්න ඕන මොන next එකේද key එක තියෙන්නේ කියලා, right? So key එක හම්බෙනකන් අපි මේක iterate කරන්න. If you make the current next and free the memory, else update the current node to the next and do the above process from step 2 till the last node, right? So මේක අපි loop එක යවන්න ඕන හන්ද මේක iterate කරනවා, right? So එතකොට අපි head node එක එමනම් key එක තියෙන්නේ very easy. Otherwise, we need to find out the key, the position, and delete. Right? Very easy. So this is the function, right? So delete node function in C. So we will pass the head. So that is the linked list and the key that need to be deleted, right? So basically it will assign a temp node, right? And then move to the head node to the next and free the head. If head data key now, then we temp head data temp assign karga, right? So basically, so this temp is to keep all the deleted items, right? Again, delete kan item meka me temp එකේ තමයි අපි තියාගෙන ඉන්නේ, right? So then head next එකේ තියනවා head එකට assign කරගන්න, then free. So if you don't need this to be stored in this temporary node, you can free up the temp, right? Right, very easy. Let's delete data 20 head node, right? So if it is head node, very easy, right? Head next එක ඊළඟ එකට assign කරගන්න. This is the resultant linked list, right? 20, 30, and remaining. For other nodes, right? So we discussed this, right? So right. So if see, very easy, right? This one, see. So this temporary is used to freeing the memory, right? Whether අපි මේ මකන node එක තියාගන්න තමයි temp කියන pointer එක පාවිච්චි කරන්නේ, right? හරි. අපි මේ key එක head node එකේම තියෙනවා, right? So if head data key now, we are lucky, right? So we are at the first node and we found out the key, right? Then we will assign the head reference to temp, right? And we will we will assign head next to head, right? So then free temp, right? If not, right? Again, head එකේම පළවෙනි එකේ නැත්තම් what we do is we need to move forward, right? So current next null වෙනකන් යනවා. If current next data key එක නම්, right? temp එක current next කරනවා, right? current next කරනවා. ඒ කියන්නේ අපි එකක් පන්නලා හැයකට දාන්න, right? Then pretemp break. So that means over. Otherwise move to the current node and process, right? So very easy, right? So if head data key now, so very easy. Else we need to go ahead and find out the key and remove that we remove the target one, right, and assign it to temp, right? And if you don't need that memory after that, you can free up the memory, right? So very easy. Okay. So visual representation. So let's delete 20. So we are going to delete 20, right? So first we need to find out where 20 is located. Once you find out, so what we need to do is we will assign current next to target next, right? So then this will free up, right? And it will assign to temp. So once if you don't need this one, you can free the memory, right? So the next operation is searching a node in a single linked list, searching an item. So I think we learned about how to search with the deletion, right? So because in the deletion we need to do search first, right? So therefore we already learned, but so searching is another operation in the linked list. So this is the given linked list, right? See, this is the given linked list, right? Having items, 4 items, 10, 20, 30, 40, right? So let's say if I want to find out 20, right? So 20. So may linked list 20 තියෙනවද නැද්ද? So that is searching, right? So if you found out, okay, found, and this is the location. Okay, if it is 100 output, so you can't find any item called 100. So then the output should be search not found, right? So if you found an item, okay, search found and the item, and if there is item which is not available in the linked list, then it will output search not found, right? So we already discussed this algorithm, right? So iterate the linked list using a loop, because we need to go through. If any node has a given key, then the return 1, right? If the program execution comes out of the loop, that means we are at the end and we did not find, then we will return -1, right? So that means 1 means search found, -1 means search not found, right? So very easy, right? So algorithm to find out an item in a given single linked list. Basically, we need to input the value needs to be find out, and then basically it will give you the output. Okay, search found in this location, right? So then in this case, input 100. Okay, so search for this item. But if you did not find this item, it will give you error message or warning saying search not found, right? So you did not find the item in a given list, right? Okay. So that is searching a node in a single linked list. So let's go to the code, right? So this is the step 1, basically. So this is okay. We have to so this is the search node is the function, and we have to input the linked list, and the value needs to be find out, right? So then first we will create a temp node and assign the head value, because we need to traverse through the linked list, right? So while temp not equal null, then temp next assign to temp, right? Because we need to find out the key, right? So, okay, this is the first step to traverse through the linked list, right? So this is to traverse through the linked list, right? So basically move forward through the list. And then as the second step, okay, return 1 on search found. Okay, now we learn up to this. If temp data equal to key, then return 1. Okay, we found this item, right? So to iterate, I mean to keep going this loop, we will assign temp next to temp. Then it will move forward, right? So this while loop is taking place, right? Okay, so else, right? The step 3, sorry, right? Else return -1. Return -1 on search not one. Mema not null net. Okay, make gihilla make එක හම්බුනේ නැත්නම් return -1. Search not found, right? So okay, so start with assign a temp, and then okay, temp dot data equal to key. Okay, then we found. If not, we will move forward, right, to temp next. So okay, temp next dot data 20. Okay, then found, then return 1, right? So if some other value, for example 100, okay, this is not equal to 100, then it will move the other one. Okay, then temp next equal to 30. Okay, it is not 100. Okay, then it will move forward. Then temp next will become null. So okay, then loop is finished, right? And we did not find any item. Then what will happen is it will give you a warning saying search not found, return -1, right? Okay, now let's look at the last step, right? So return -1 on search not found, right? So this is the complete code. This is the search not function, right? So we will input the linked list as well as the key need to be found out, right? So basically we will create a temp node and assign the head value and then traverse through the linked list. If temp data equal to key, then return 1, and then temp next will assign to temp to move forward. Okay, if nothing happened during this one, that means there is no key to be searched, right? So then it will return -1, right? So return 1 means search found, return -1 means search not found. So very easy, right? So this is searching, and the visual representation. Okay, this is searching 100. Okay, temp data. Okay, it is not equal to 100. It will go to the second one. Okay, data 20. No, it will go to the last one. Okay, data 30. No, it is not 100. Okay, now we add the end of the linked list. Okay, that means we don't have any item called 100. Search not found. Right? Very easy. So that is visual representation. So implementation of searching node list. So what I will do is searching. I think okay. Search. Yes, I already written down the code. So this is search 1. Right, same thing. Right. Right. So let me increase the font size. Then you will be able to okay. So this is searching an element in the linked list, right? So we will create the structure and at last search node main, right? So this is the complete program for the search, right? So I will share this code with the lecture note, right? So then you will be able to write your code and compile and see, right? So the output. Okay. So then reverse operation, right? So reverse means basically we will reverse the linked list, right? So what the reverse means, right? Now what we will do is we will totally reverse this. This is the given linked list, right? So this is the given linked list. So this is head, and then head. This is the node, first node, and the first node that next. That is the second node, and second node node next. That is null. So this is the given linked list. Now we need to reverse. Basically, what we need to do is we need to reverse this, right? So reverse means we will remove this and point like this, right? And then remove this, right? And point like this, right? And this will become the head, right? මේක අනිත් පැත්ත හරවන එක කරන්න. මේක head වෙනවා. මේකත් මොකද වෙන්නේ? මේක null වෙනවා. Right? Then this will become the head node, and then this is the next node, and this is the last node, right? And then last node next will be null. So it is completely reversed, right? So we need to make the last node to be pointed by the head node and reverse the whole linked list. The last node head node reverse one, right? So vice versa. So it will change all the nodes addresses, and the first node dot next becomes null, because that will be the last node after reverse, right? Okay, let's see. Okay, so let's see the reverse operation, how it works. So we traverse to the end of the list. First of all, we need to find out the end. මේක reverse කරන්න කලින් අපි මේ link list එකේ end එක කොහෙද කියලා හොයාගන්න. මොකද අපිට link list එකක් අපිට දෙනවා. ඒතකොට දෙන list එක අපිට reverse කරන්න කියලා කියන්නේ. එතකොට අපි මුලින්ම හොයාගන්නවා මේක end එක. මොකද end එක point වෙනවා head එකනේ. එතකොට මුලින්ම end එක හොයාගන්නවා. So first we traverse to the end of the list. It should be pointed null at the moment. And before reverse, so the last node should be pointing to null. Right now we shall make it to point to this previous node. So now what we are going to do is we shall make it point to the previous node. Then null වලට point වෙලා තියෙන එක point කරන්න ඕන. දැන් ඉන්න තැන නම් previous එකට. ඒ වගේම ඒක head එකට assign කරගන්නත් ඕන. Right, so those two things need to be happen to start the reverse. Right? We have to make sure that last node is not lost node. Right? So we have to make sure that last node is not a lost node. Right? So we have some temporary node. So අපි temporary node එකට දාගන්නවා. මොකද අපි අන්තිම එක්කෙනා හොයාගෙන ඉවරනකොට search කරලා හොයාගෙන ඉවරනකොට list එක නැති වෙන්න බෑ. Linked list එක නැති වෙන්න බෑ. ඒකද so we have to make sure that last node is not a lost node. So we will have some temporary node like searching, insertion, everything. So we used temporary node, which look like the head node pointing to the last node. Right. So now we shall make all our left side nodes to point to either previous node one by one. From making a previous node එකට point කරනවා. එතකොට last node dot next කියන්නේ previous node වෙනවා. Right? So to completely reverse the total linked list. Right? So except the node, first node pointed by the head node should point to their predecessor and making them to their new successor. The first node will point to null. So because at the end, after reverse, the first node becomes the last node, right? So after reverse, so then the first node will point to null. Finally, after reverse completed, right? So the first node will point to null. Okay, now see. last node dot next point to the previous node, right? And the first node dot next point to null, and the head node will assign to the first node, right? So then this total linked list reversed. So this is the total implementation, which is having, the complete code. So basically, to print list, insert first, delete first, it's empty, right? So all the functions are there. So this is kind of a complete code, deleting a link, navigate through list, right? So reverse and the main program. So basically, this code is having the total program, total linked list with all its operations. So I already shared this lecture note with you. So try to implement this code using C. So this code is written in C. So you will be able to follow this code and try to implement, right? So then you can write the code to compile and run, see how it works, right? Okay. So with that, so this kind of a result, so the original list is given and the deleted values, right? So like that is this. So this kind of results, but you need to do this, right? You need to get this output by writing this, the previous code, right? So please go through the code and try to get this same output, right? So the same thing is there, but you need to understand the code a little bit, right? So because the everything is not in the main program, so I wrote several functions, so and call these functions inside the main program. So that need to be understood, right? In a module way, right? So that is all about single linked list, right? So now let's look at the behavior of a doubly linked list. So we are not going to discuss the operations of doubly linked list. So just introduce the doubly linked list and say how it works. But in a single linked list, you need to understand all the operations and their algorithms, right? So their implementations by practicing. But in double linked list, you don't need to do that much, but you need to understand the concept, right? So in double linked list, so I think at the beginning right, so in the double linked list, there are two references, next and previous. So here you can see containers, right? So in this example, there are three containers. In one container, let's look at one container. So you can see three compartments, right? One is to store data. So this may be any data type, right? And then there are two references. One is to represent the next container, and other one is to represent the previous one, right? So then basically, it will be able to navigate to both ends, next and previous, right? So, and here you can see, and if you look at the first one, so the head is representing the first container, and but the first one dot previous should be null, right? So make it right, and also the last one dot next should be null, right? So both the last one next and the first one previous should be null, right? Because we are talking about doubly linked list. So if you look at doubly linked list with circular way, so the all null values will be removed, and the first one next will point to the last one, and the last one previous should point to the first one, right? So like that. So if it is circular, then this scenario becomes a little different, right? But in a doubly linked list, the last one next should be point to null, and first one previous should be point to null. So then there won't be any movements. right? So with the previous and the first one previous and last one next. So that is the end, right? So the same concept further developed, right? So with the doubly linked list, the difference is in doubly linked list, in a container is having three components. One is uh, to store data element. Other one is to represent next node, and other one is to represent previous node. So then it will be able to traverse through both directions, the next and previous. Right? So next and previous. So basic operations very similar to the simply linked list, right? Simply linked list. Insertion, deletion, insert last, delete last, insert after, delete, display forward, display backward. So likewise, there are operations, but we are not going to discuss these operations in details. That means we will not discuss algorithms, their implementations using doubly linked list, right? So this is just for your understanding how doubly linked list looks like, right? So then you will be able to understand. So circular linked list. So there are two types of circular linked list. One is singly linked list as circular, right? So the singly linked list as circular විදිහටම right? Sorry, students, I had a call. Sorry. So in circular linked list, there are two types. One is singly linked list as a circular. Other one we call doubly linked list as circular. So the difference is, I think you can understand. So in doubly linked list, you can move forward and backward. But in single linked list, you can move backward only at the last node, right? So for example, you can see this diagram. Right, so this is same single linked list as circular. This one, right? So here you can see these are the data containers, right? So having two compartments because this is single linked list, right? So one for data, other one for the reference, right? So but when it becomes to circular, so what will happen is basically last node. In a normal single linked list, what will happen to the last node dot next? So it should point to null, but here it should not point to null. It will point to the first item. See, first one. So then it will create a circle, right? So that's why we are saying single linked list as a circular, right? So that's all. But in doubly linked list, see, in a container there are three compartments, right? Three compartments, right? One is to point to the next node, other one is to point to the previous, and also compartment to store data, right? So when it becomes to doubly linked list as circular, what will happen is, right, the last node dot next become it will point to the first node. And also the first node dot previous point to the last node. So basically you can traverse to any way, right? So you can, if you need, you can move forward or backward, or you can traverse to the end, and also you can come to the front. So the navigation is very easy, but the structure become little bit complex, right? So when we are working with different operations, right? So the structure become complex, but the navigation becomes very easy. So so depend on our requirements, we need to select whether we are going to use simply single linked list or single linked list as circular, or double linked list or double linked list as circular. So that depend on our data definitions, right? So the simplest one is single linked list, and you need to understand what is single linked list and the basic operations associated with it. But when it comes to circular linked list, right? So doubly or singly, so you don't need to understand, but you need to understand how the data structure constructed. So that need to be understand. But specifically, we are not discussing about the operations associated. The operations associated with circular lists. Okay, so that is all about linked list as per your syllabus, right? So then we need to move into queues. I think we don't have time to start queue, right? So anyway, I will discuss with Prabhashana and try to arrange online lecture in some convenient time. So because today you had some issues with power, but so I will try to discuss with Prabhashana and try to find out some convenient time to complete the rest, because we need to go through several lectures, right? So basically, we already completed up to linked list. So then we have to start with stacks, right? So then trees and graphs. So and also searching and sorting techniques, right? So basically, after completing queue stacks, right? So then we have to start graphs, data structure, and the tree data structure, and different searching and sorting techniques. So with that, we'll be able to complete the course, right? So what I will do is I will talk with Prabhashana and try to find out some convenient time for online lectures. But today we had some issues due to power failures. But it is important, very important to have interaction during the class. Because I need to observe and monitor your progress, right? So, I mean, we need to progress gradually. So, I prefer if you can do some of these tasks and share a screen, then I can understand. So you are doing, you are on with this, right? So if you are not on with this, then I need to do some extra work to get you back into the right track. So anyway, so next session will be more interactive than this, and I will try my best to do that. So basically, we have to start with queue, stacks, and then a tree and graph, and then searching and sorting. And also, we will discuss some practical applications, right? So we need to understand why we are learning this kind of data structure, right? So that we will also discuss, right? So I think with that, I will conclude the lecture today, right? So after discussing with Prabhashana, I will try to arrange some convenient time for online lectures. And also, I will give you assignment based on linked list, right? So that will be your third assignment, and I will give you the assignment with all the instructions. So basically, you have to email your report or assignment to the given email address, right? So